Please turn your microphone off if you don't mind, just so that it's muted for everybody, if you don't mind. Today's presentation is based on fabric performance. Sorry, I'm going to say again, could somebody turn the microphone off, please, if you don't mind? If you're interested, get on down to our place, give me a call, obviously, in advance, and we'll see can we facilitate you in our CPD area. Just another little reminder that somebody who's just joined us there, please turn your microphone off if you don't mind, just so that it's muted for everybody, if you don't mind. Today's presentation is based on fabric performance. Sorry, I'm going to say again, could somebody turn the microphone off, please, if you don't mind? Today's presentation is based on fabric performance calculations, U-values, a bit on Y-values. I'd like to think that you all pretty much know what's going on through this presentation, but it's just to give you a heads up and to let you know our point of view, really, I suppose, on U-value calculations and where you can get the information from, etc. So, like I say, without further ado, as the fellow says, just a bit about the company. We are now known as Unilin Insulation. We were known for many years as Extratherm. We have changed our name last year to Unilin purely because the company who own us, Unilin, asked us to do so. We started back in 1986 making white and grey polystyrene under the name of Hytherm. In 2002, when I moved over, we started Extratherm, which I think was a fantastic name. We were told we could keep that, but nevertheless, we last year moved on to the name Unilin. The only difference for you guys to know is the foil now states Unilin. The Extratherm foil is gone, and it now states Unilin. All the product codes are exactly the same. There's nothing different to look at there. But ultimately, what it's done is it's brought us into become one of Europe's largest PIR manufacturers, with plants all over Europe. Ultimately, I will show you in a moment. But you know, it's about getting the name out there. We haven't had any problems since we started being Unilin. It's just getting the name out there and throughout you guys to make sure that you're aware of who we are and what we sell out. If you look at the product, for instance, going right to left on your screen there, we'll start with the full fill insulation. That's our biggest seller. The full fill insulation gets the best U value in any masonry cavity wall than any other manufacturer of insulation out there. We then have the pink board, which is phenolic insulation. Quite frankly, the only reason we did this is because Kingspan were the only manufacturer doing it, and we thought we'd put the stop on that a wee bit. We've got two different types of PIR, or polyisocyanurate, if you want to use the proper name. One with print on, one with a plain foil. Sorry, could I just ask again for you to turn your microphones off, just to keep the volume off? Thank you. The foil with the print name on is our basic thinner range. The foil without the print on, quite frankly, I was asked about 20 years ago to measure how much print is on the board that does not reflect into a cavity rather than the foil. And believe it or not, there's 11.2% per square meter. So we had to remove the print so that it is pure foil, reflecting more into a dead air space. So it gives you a better result. We have XPS, which is designed for heavy loadings in floors under car showrooms, retail units, etc. We still do white and grey polystyrene. We have a non-combustible stone wool, but please be very careful just having that specified in any masonry cavity wall, for instance. It widens the wall out far beyond what is normally built in this country, and we have all kinds of problems with it. We also sell out foam glass, which is down the bottom right hand side there. Foam glass is used typically under a threshold detail, also at thermal bridging details. It is quite expensive, but it gets the job done. Our factories throughout the world, we started in Navan, County Meath in '86, like I say. We then, in 2005, put a plant into Chesterfield across the water. We've just bought Ballytherm Insulation, which are the two plants. We've got one at Ballyconnell and one at Ross-on-Wye. But if you look at the rest of the world, we have a plant in the Netherlands. We have two plants in Belgium. We have a plant in France, two plants in France, actually, sorry. So we are, like I say, one of the largest PIR manufacturers throughout Europe. So, we have become the top dogs, if you wish. The technical team, there are actually a couple of members missed off here, just recently added to the team, but I suppose internally it is headed up by Eamon Clark and Mark McGuinness, who are the technical managers. Then you have the other guys who are running calculations all day long for everybody, the U-value calculations, thermal bridging analysis, etc. Then on the road, we have myself. I cover anything from Drogheda across to Roscommon, Dublin, down to Wexford. Ray covers the whole of the west coast, all the way down, including Cork and Waterford, and Francis covers Northern Ireland. So we have quite a large area to cover, but we like to keep you involved with all of what we do throughout our business. If you need to meet with any of us, give me a shout, and I can organise that. The technical team themselves, we're all qualified. Saying all of us who ever did U-value calcs through the TIMSA BBA competency scheme for U-value calculations and condensation risk analysis. That was ultimately came many years ago because, quite frankly, there was no scheme in Ireland to say that we were qualified to do U-value calculations, so we had to go to the BBA. I was one of the first ones, along with Mark McGuinness, to get certified through the scheme. Mark himself is qualified through the BRE and the NSAI thermal modelling competency scheme. So he looks at the thermal bridges and how to combat that. And all of the team are certified through the DEEP and SAP assessments, energy assessments programs, if you wish. I was, again, one of the first ones on the courses that started many, many years ago. And we have assessors working with us throughout the business, so we can tie in with you all and help you all for what you're doing. So the first thing I suppose we've got to say is fabric performance. It's when we are looking at U-value calculations, when you guys are looking at U-value calculations, we need accurate measurement and exact build-up of the wall, floor, roof in order for us to give a correct result. It should really be verified with agreement certification. If you can't have agreement certification, you really need to look at the likes of the CIBSE guide. I don't know whether you've heard of that before, big book. Most people use it to chop up their screen. But it's actually a useful book, but it gives lots of details in terms of looking at, I suppose, values for insulation, plasterboard, timbers. But these values are much worse than certified products. So be careful that if you can't get a certified figure for, we'll say, lambda value, etc., you have to go to the CIBSE guide. That's written into our regulations still to this date. But as I say, when you're looking at doing a proper U-value calculation, you need to be looking at the exact measurement, the exact build-up to get the correct result. Just a summary of the minimum targets for today's standards, just to run through it very quickly. 0.18 for walls. Just in our terms, you're looking at about 110 mil in a 150 cavity. Nothing unusual there. Roofs, 0.16. That's your 3 to 400 mil fiber, depending on what you're using. Floors, 0.18. Again, that's somewhere in the region of 100 to 120 mil of insulation, depending on the floor area and exposed perimeter. However, please be aware that if you've got underfloor heating, you need to have the U-value no greater than 0.15. With windows, it's 1.4, so you're looking at double glazed, possibly triple glazed in some cases, but you can get double glazed windows down to 1.4. The thermal bridging, it's now encouraged to calculate the Y values, and I know a lot of assessors will not do this, but have a look at it. It's quite simple and easy to do. I will run you through it later on. Air permeability is 5, so that's natural ventilation at worst case scenario. Obviously, the MP, EPC and the CPC have dropped a wee bit, but the one thing I want to talk about is renewables. Today, we have a 20% contribution must come from a renewable source. And I'm going to be honest with you, it used to be about 12% if you look at the old standard we used to work to. But it's now 20% contribution. And I do think in this country, we're making the biggest mistake by doing that. I think renewables are great. However, everywhere else throughout Europe, they make sure that the building is sealed properly first, with insulation, thermal bridging looked at. And then it is, I suppose, if you want to use a renewable, you can. which most people would choose something like a PV or an air to water heat pump, etc. But in like I say, within the Irish regulations, it is a contribution of 20% that is mandatory, and I think we need to be careful with that. Air testing: all dwellings must now be pressure tested through Part F. So that's the summary of the minimum standards. Let's get this to move on a wee bit. If you look at the Part L, in Part L there's an example house, if you wish, and that gives values for walls, floors and roofs. Remember I said 0.18 for your walls, 0.18 for floors. These figures are much lower, and quite frankly that's purely because it doesn't work meeting the basic minimum requirements. You have to go slightly better in most cases in order to get this to comply. There is a passive house standard there. You'll see values better than 0.15s, etc. The thermal bridging is an issue with passive houses. It must be less than 0.01, whereas in Ireland in the example house it is 0.05. We've put a standard together. Our typical standard is 0.15 throughout walls, roofs, floors, but also a Y value as low as 0.03. And you may think that is ridiculously low. I have calculated it out to 0.02 before quite easily. And it's just a case of calculating the junctions, which we'll demonstrate later on through the presentation. But first, let's look at the basics, really, the very basics. What's a U-value? A U-value is the amount of heat loss through a given area, which is typically 1 square metre of wall, floor or roof. It is based on a couple of things, mainly the lambda value, and it is pronounced lambda and not lambada, as I've heard. I believe that is a dance. Lambda value is the thermal conductivity of the product, but also the thermal resistance based on the thickness. So these need to be calculated accurately. Lambda value, like I say, is the heat loss through a particular product, whether it be a block, piece of insulation, a plasterboard, etc. Plaster also. We've got our certified the Lambda 90-90 principle, which basically says 90% of the production is equal to or better than the figures we've given, and it is actually an aged value. So when we say that our best insulation is 0.020 lambda value, in reality it's probably something like 0.017, but we have to give an aged value when we calculate. The resistance, like I say, is what stops the heat from getting through, and that is measured. It's based on the thickness of a product and the lambda value. It correlates and calculates out. So let's get rid of that. If you look at typical lambda values throughout the market, if you look at PIR, obviously we produce that. That's 0.021 at normal standards within our factory. You've got grey EPS, which is the next best product we do, which is 0.031. Grey pumped bead is as low as 0.033. White EPS, which is the polystyrene again, is 0.038. And fiberglass at worst case scenario is 0.044. So you can see that basically the fiberglass is almost, well, near enough, twice the thickness of the PIR if you're looking just a direct equivalent. To give you the direct equivalent, ignoring air spaces. Now remember that PIR has foil on it, and when the foil reflects into a dead airspace, it gives you a benefit of somewhere between 15 and even 25 millimeters of insulation value. So ignoring those air spaces, just a direct equivalent on those products, you'll see that 100 millimeters PIR is equivalent to, let's say, 210 mil of fiberglass. Sorry, could I just ask somebody to turn the microphone off there, please? It's just interfering. If you don't mind. Thank you. Nope, we're still on. Could somebody please turn your microphone off there? Thank you. However, you have to take into account realistically air spaces when it's calculated. And I, for one, had a project in Belfast that was calculated by my, I suppose, the architect at the time. It needed 150 millimeters of PIR insulation in the cavity, fully filling it. And they were going to use a grey pump bead, which, if you look at the calculation there, would be around about 200 millimeters. However, when I calculated it accurately, and once you go over 150 mil, you need to include more wall ties. When we put the more wall ties in, the double the amount of wall ties, it increased the amount of insulation required, and so on and so forth, until we met the U value of 150 millimeters of full PIR. It actually equated to nearly 300 millimeters of grey pump bead to get the same value. So just be very careful when you go over 150 mil cavity. You need to include more wall ties, different types of wall ties potentially. And there's also the cost of digging out, putting an extra wide foundation in. It all becomes very expensive to use a cheaper product like grey pump bead rather than using a standard PIR board. So value engineering based on that, then, is it really more cost effective? No, it's not typically. Look, we manufacture polystyrene out of grey bead that is used in cavities. But when you factor everything into it, the wall ties, like I say, a standard stainless steel wall tie will cost roughly today's money about 30 cents. A strap tie that you need over 150 mil cavity, certainly on a 300 mil cavity, will cost you about €3 a tie. Take that into account. Take in the extra concrete in your foundation. It becomes more expensive to use a cheaper product. Is the U value the same? Well, typically not, unless you calculate it properly. Does the architect have to change the details and resubmit to planning? Typically, yes. I've actually had an architect saying to me he would not change from his design because it would all need redrawing and rechanging. And does it have an impact on site layouts? Typically, yes. We had a site in Manchester, a straight line of semi-detached houses, and they decided to switch from our full fill over to bead again. And by the time they got to the end houses, there was not enough space to put the semi-detached house in. So they just had to go with one small house instead. They lost a full house, and it was only 15 houses in a row. So not too many. So just be careful on value engineering. It's not always value that you get at the end of the day. Our details are all confirmed within NSAI specification, or BPA in the UK. Our lambda value or thermal conductivity is always within these documents, certified. Also, it's in the DOP, the Declaration of Performance, which is the new CE marking. I'm saying new, it's been out for many years now. But this is actually circled there for you. The thermal conductivity is always listed within this document. And this document is a document in law. Our director, if you wish, our managing director, he has actually had to sign these documents to state they are a document in law, and he will stand by these figures. How you declare the U-value results, quite frankly, I've seen too many of these. I was doing U-value calculations 22 years ago, 21 and a half years ago. And like I say, we had to get certified to do them properly. There is a way of doing a rule of thumb calculation, but we prefer to do the competent calculation. I've seen many calculations done to 3, 4, 5 decimal places. In the regulation, it tells you you have to do it to 2 significant figures, which can alter the U-value calculation at the end of the day. And if we look at this, and I know I've got extra therm name in there, just quite frankly, because we are the same company in essence, but also it's a good layout. This is a cavity wall build-up on our software. You'll see the plaster, dense concrete block insulation, a low E cavity because it's got foil on the insulation, so it's low E emissivity. Dense block outer leaf and external rendering. You'll see there that we have our figures to put 2 decimal places, 0.18. On that particular brand, if you wish. Some standards for the U-value calculations, and I would beg you to write the first one down and look into downloading it, get it off the BRE website. I think it's BRE Bookshop you need to look at. BR 443 is the conventions for U-value calculations, or as I like to call it, the Bible for U-value calculations. Everything you need to know in there, all the regulations, all the details, in our part L refers to part BR 443. And quite frankly, if you're doing U-value calculations, you should know that document near enough inside out. There are 2 other standards for the U-value calcs that we do, is 6946 and 13370. They look at the building components, the elements, and the thermal performance of buildings. So looking at condensation risk analysis, etc. Other reference documents that we constantly refer to is, of course, throughout Europe, etc., is the accredited details. In Ireland, we call them the acceptable construction details. I think the name lets us down a wee bit, guys. but never mind. The SIPSI guide, as I mentioned before, gives worst case scenario figures. BRSD7 timber frame. If you're doing timber frame calculations, get that document. I personally did all the U-value calculations for the BRE for that document, and we are associated in the document. And certainly, if you're looking at ever doing calculations with steel frame, you need to look at the BRE Digest 465 steel frame. And even our guys to this date in the technical office running U-value calcs, they always have that open if they're running a steel frame calculation. There's a lot to do with the webs, the thickness of the steel, etc. And of course, if you're looking at any good building guides, the BRE good building guides are the ones to go to. For instance, GBG 45 is the good building guide from the BRE, which talks about using a separating membrane on top of insulation before putting screed over the top. That's quite frankly just to stop the screed from going down in between any joints. It's not for any other reason of burning off the foil on the insulation or whatever you've heard. But the BRE good building guides are a good one to get into, guys. So when we look at basic guidelines for U-value calculations, but again, you'll know a lot of this, but let's go through it. All repeated thermal bridging should be accounted for in a U-value calculation. Of course you have to, because otherwise it's just a plane of insulation, and that doesn't give a true reflection on the value. I have actually seen a timber frame calculation by another... Oh, sorry, could you just mute your microphone, please, if you don't mind? Thank you.
Apologies.
Thank you. So all repeated thermal bridging should be accounted for. As I say, I've seen a calculation of a timber frame building that was just one piece of insulation running straight through. Sorry, guys, would you mind turning off your microphones? Thank you. So it gave just an R value, if you wish, for the insulation. It didn't account for any of the timber frame. The actual thickness of materials should be used, obviously. And that mainly comes down to a timber frame building where if you compress fiberglass from, we'll say, 200 mil down to 100 millimeters, you can only account for 100 millimeters of the insulation. You cannot account for 200 mil. Fiber works by keeping air stored within the material. When you push that out, it loses its ability to retain the heat. Thermal values of materials should be taken from Agmansert. I've already stated that, otherwise taken from the SIPSI guide. Cavities, not well ventilated, if you want to call that, within a masonry cavity wall, can be included in the calculation, and a foil facing one side of that cavity will create a low E nocivity value and increases its value significantly. So that is literally the basis of us using the foil insulation. However, obviously, if the foil isn't facing a cavity, it has no contribution, i.e. in a floor slab, it is totally covered by a screed. And any materials above or beyond a well-ventilated cavity, we'll be looking at, say, something like a rain screen cavity or a ventilated roof. You cannot include them in your construction, so you just have to put them in as a 0 if you want to quite simply detail them in the calculation. But yes, the BR443, that's the document there, guys. I would strongly suggest you get it. It talks about surface resistances, airspaces, timber frame proportions, etc. And I would say that, quite frankly, all the guys in our technical office who run the U-value calculations, myself included in the past, we probably could look at that and we would know it inside out to within a few pages. It is what you really need to be looking at when you're doing calculations. To give you a few ideas on the guidelines, here is another cavity wall build-up with the extratherm. We call it Unilin extratherm, whatever, low E cavity. And in here we have a resistance of 0.713. However, in an external cladding system, as I've said, anything beyond the cavity, which is 0, you have to ignore. So you ignore the external cladding, you ignore the cavity, because it's fresh air. It's like being out in the car park. So it has no value to the calculation. You can see the figures there circled. With cavity walls, as I've stated, when you get above 150 mil of a cavity, you will require either double the amount of wall ties or a strap tie, which is much thicker. If you think about a stainless steel wall tie, You cut that in half, you've got a cross-sectional area of about 13 millimeters, 1-3. If you cut a strap tie in half, it's approximately 80 millimeters squared. So a lot more steel is going through the insulation. And you must account for them in the U-value calculation. It is repeated thermal bridging throughout the insulation board. If lightweight blocks are used, you must incorporate the mortar fraction of 8%. Quite frankly, the way that works is a dense block is roughly the same value as mortar, but a lightweight block is much better, so it's then thermally bridged by the mortar, so you have to include the mortar fraction. And the likes of dry lining plasterboard, the cavity behind that can be added. Again, in BR443, it tells you the values to use for that and what thicknesses to use in your calculations. But here's the crunch. For many years, and I would say I've had BR assessors, I've had architects, I've had engineers on the phone to me claiming the figures I'm using in my U-value calculations are bizarre, I think is a word to use. And it's all down to this thing, the resistance in the cavity being used. 0.18 is the resistance coming off me right now, the resistance coming off my computer screen, the wall, the carpet. It's anything that is basically just a fair-faced product. If you use a foil-faced product, you get 0.44 of a resistance in the cavity rather than 0.18. And in actual fact, it says you can use, this is from BR443, a higher airspace resistance if it's been accredited by the EU National Accreditation Service. We can claim as high as 0.713 with our extra liner, 0.665 with our standard thin R products. And that itself can make a difference of near enough 20 millimeters of insulation value. So just be careful when running calculations with foil on. You can immediately put 0.44 as a resistance rather than 0.18. I look forward to the comments later on that if you wish. There's also something to do with the tolerances, the gaps, the jointing of insulation. You have to, as per 6946, the document I mentioned earlier, include a level 0, level 1, or level 2 in your calculations. So level 0 is quite frankly a tongue and grooved board, something that has no gaps exceeding 5 millimeters, etc. Blah, 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 blah. It's a tongue and grooved board. It's an engineered jointed board. That means there's 0 penalty to add to the U-value calc. If you go to level 1, that is something like a square edge board, and you have to add 0.01 to your U-value calc. So you may think that your U-value is actually achieving 0.18, but if you're using a square edge insulation board in the cavity, you have to add this. Oops, sorry, I'll go back. You have to add this to the U-value calc. You will actually be getting 0.19, and it will be outside of regulation. Likewise, if you use a fiber material, for instance, you have to add 0.04. So again, if you think you're getting 0.18, you're actually getting 0.22 in your cavity, 0.22 of U-value. So just be careful that these values have to be added to your U-value calculation once the U-value is calculated. With our materials, as I said, the tongue and groove jointed systems, there's a corner panel, for instance. The corner panels are, by the way, guys, the same price as the regular cavity wall boards. It's just we make them with a V cut into them and they fold round the corner. Quite simple. But in the BR443, it tells you about these jointing systems. There is another extra liner board that is tongue and grooved all the way around all 4 sides. All right, that's been cut off here, but it is tongue and grooved all 4 sides. And again, that's 110 mil in a 150 cavity, keeping it traditional width cavity, using standard stainless steel wall ties, 0.15 of a U-value, well below the regulations. The full fill insulation that we have, and that is just a 1 millimeter plastic skin that is already glued onto the PIR with a raised edge towards so that the mortar doesn't drop down onto the insulation. That's 150 mil in the traditional cavity width, and that gets 0.13. So here we go. There's a U-value calculation showing the plaster dense block, our standard build in Ireland, but with a square edge PIR calculation. Now, I'm sure you can all work out the U-value there is 0.26, right? And a lot of people will say we don't get 0.26 because of this value here, the resistance of the cavity. which is now 0.665 with this basic product that we're using. But if you go to a tongue and groove board, that U value immediately comes down to 0.25. So, I mean, I know we don't go to 0.25 these days. This is just an example. But that's quite simply by just using a tongue and groove product. So just be careful there, guys. There are lots of little catches. The variable cavity width comes into play as well. So here is our extra liner in an 80 millimeters with 40 clear cavity. And yet over here, we have the full fill insulation that has a 5 mil clear cavity, and the resistance has gone from 0.713 down to 0.109. We calculate all of these values for the resistances. With walls, timber frame, like I say, the maximum thickness you can put into there is whatever the depth of the studs is, and it doesn't matter if you double down the insulation from 200 mil down to 100 mil. You can only account for 100 mil, or like it says 89 mil, or whatever it is. Check BR paper SD7 and it describes that for you. The BR443 tells you must use 15% timber fraction for these timbers because they are repeated thermal bridging as you go along. I will state that I have personally been out to a house in just opposite our factory, actually in Navan, and measured exactly how much insulation was required on a timber frame wall. And believe it or not, there was 36% timber, and that is not unusual for a timber frame house. So I think 15% is quite generous to us doing U-value calculations. And that's the figure we use in our U-value calculation. We say is the material bridged, yes, by what timber and at what fraction, 15%. With floors, it's quite simple, really. It's based on perimeter, exposed perimeter, that is, and the area of the floor. Areas such as unheated garages and porches should not be included. The soil conductivity, this is one that gets me. UK conductivities differ from Ireland, and you need to be verifying those. I'm sure you guys don't do calcs in the UK, but there's something coming up that I need to talk to you about. Dense slabs and coverings like vinyls, carpets should be ignored. Vertical edge insulation, of course, should be provided to all floors. And if a floor is above a well-ventilated area, for instance, a car park, it's not actually deemed as a floor, and the perimeter area ratio cannot be used. So the build-up should be calculated as an exposed element separately. But there is just an example of a semi-detached house. The purple line is the exposed perimeter that you should be measuring only, and the area then of that within there is the area of the floor. And those are the figures we use all the time to calculate. That's what you should be using. I will say that measurement should be done at skirting board level, guys, not externally. Obviously, if you measure it externally, you've got the width of the block all the way around it, increases the area of the floor. So just be careful there. As I say, I hope I'm not preaching too much to the guys who know it all, but just bear with us. There's something great coming up. Flat roofs, you're looking at, I suppose, flat ceiling, sorry, 0.16. Look, it depends on the fraction of the roof. If you lump all of the timbers together in a flat ceiling, you're going to have 12.5% timber in that roof, totally uninsulated. So that's why we have to cover insulation joists, with insulation to cover that thermal bridge. With dormer roofs, you typically need a well-ventilated 50 mil cross-floor ventilation. However, if you're using a breather membrane, you might be allowed to get rid of that ventilation, but be careful. I was chatting to one of the big guns the other day, and they stated that their membrane, you still need 50 mil ventilation. And this comes back to 2016 when we had the terribly cold winter, minus 10 degrees, and nearly everybody in Ireland died. We did manage though. And they stated that you cannot use a breather membrane without the ventilation. So just be careful there, guys. You have to include that. With slope roofs, as the typical way we do it, where we insulate between the rafters and some insulated plasterboard on the underside, you're looking at somewhere like 125 between a 175 rafter with 50 plus plasterboard on the underside, giving 0.15. Or the better way to do it, using a tongue and grooved insulation 8x4 sheet over the top of the roof only, calling it, and this is the warm roof system, No insulation within the rafters. That's the cavity wall insulation coming up realistically. But it's just sitting on top of the rafters. It's the best way to do it. 150 mil of that will get you 0.13 all day long on your roof by itself. So down to the crunch here, guys. And this is where I love talking about this. The BRE U-Value Calculator. I'm sure, I don't know how many you're on now, actually possibly close to 200 people on this presentation. I'm sure you've all been guided to use this software in the past. I would beg you to be very, very careful, because I would state that if I went round and measured 90% of floors in Ireland, they would possibly fail the regulations, and there's a big reason here. We've got to be careful of the lambda value of the product, the layer thickness, the low E in cavities, correction for air gaps, and wall tie data. Firstly, when you're looking at walls, you'll see this cavity here. This cavity, we'll say this is foil-faced insulation, as most products are these days within a cavity. The cavity is 40 mil with a resistance of 0.18. That's incorrect. The correction level is set at 1. So before I said you had 0, 1, or 2. Realistically, it should be 0 because it's a tongue and groove board. Ours is for sure, as are others. No air gaps in the layers. The wall ties are in as strap ties. Now, I said 80 millimeters cross-sectional area. If you change that value down to 13, as a stainless steel wall tie is, this U value here will change dramatically. Okay, so let's have a look at it. We've chosen a 40 mil air gap. We've made it unventilated, which it is. We've specified the emissivity, and it's going from 0.19 down to 0.15 because we've changed the correction level back to 0 as it's tongue and groove board. We've changed the resistance up here because we can. We've changed the number of wall ties. Strap ties are not used in cavities up to and including 150 mil cavity in Ireland. Okay, so all these details we have changed. But one of the key point that we have changed is the floor detail. In this software, this is a UK software. In this software, it states that the soil conductivity is 1.5. That is a UK soil, which is drier than Ireland. In Ireland, we have to use a figure of 2.0 as opposed to 1.5. It tells us this is the soil type. It tells us in part L that we must use a conductivity of 2. And yet every single calculation I've seen, going back on that software, it's in the floor as 1.5, which is UK. And if you change it, it will make a difference of probably 25 to 30 millimeters of insulation for the worse if you change it to 2. So that means if you've got your floors at 0.18 exactly, and you've been using 1.5, they will fail the building regulations if you change it to 2. Please be very careful with that. Spread the word. I've spoken to a number of people doing the assessment training and guided them on it. Spread the word through your friends. It should be down as 2 for the soil conductivity. Okay. So thermal bridging, what is it and how do you calculate it? Very, very quickly. We all know about thermal bridging. For years, we've been looking at thermal bridging since 2002. Thermal bridging is basically where, what's the best way to describe it? Where the insulation stops or breaks, and there is something between it and the next lot of insulation. There is a classic example that was done on the apartments at Phoenix Park Racecourse, for instance. And the cold, quite frankly, is targeting this outer layer, coming straight across the slab into the room where 21 degrees is. And the 21 degrees hits the cold, condensates. And you can be guaranteed within a year, we had a phone call from the developer of this saying that their solid wood skirting boards of these apartments had gone black. Quite frankly, there's 30% of your heat loss comes from the thermal bridges within buildings. So you're talking about your wall to floor heat loss, your wall to roof heat loss, your head, sill, jamb, corner, anywhere there's a section of the wall, roof, or floor that is broken, the insulation is broken. Okay. It's told us for many years now in Part L to make sure continuity of insulation and to limit local thermal bridging, and that any thermal bridging should not pose a risk of surface or interstitial condensation. There are values that we can use when doing the thermal bridging analysis. You know, the default in your software is 0.15. If you use the ACDs, it can be as low as 0.08. If you do a calculated version, it can be down as low as 0.02. And you can also do a combination of option 2 and 3. Again, you could get as low as 0.02. And just to look at a side value here, so that's our U value per square meter, if you wish. It's missing out the corner, and we have to model that up. We've done all of the ACDs. They're all modeled up on our website. That is a side value looking through there. Like I say, it's the property of the thermal bridge and the heat flow, and it's not accounted in the U-value calculation. There's certain standards that you can use. I can send these on to you to share as a PDF if you wish. Going forward this presentation, maybe Stephen, you could share it out, or Barbara, you could share it to the team. Different standards that we've used over the years. IP 106 is one of the classics, describes exactly how to do the thermal bridging. It's a bit old now at this stage, but it's still relevant. We ourselves bought Physabel. It's a 3D analysis to look at the junctions. This here is the joists going into a wall, and when you look at the 3D, you can see the joists come through. It establishes the heat loss through it. But you know that we can all turn to Part L. In the back of Part L, there are the junctions for cavity wall, external insulation, etc., etc. You can read them yourselves. It gives us different options for the floor, for instance, depending on the section in the ACDs, and different values to use, and you can pump them into your software and create your Y value or thermal bridging analysis. Like I say, we have modeled up all of the ACDs, all with our details. It's got the side values here for you. There's 4 of them. We've done all of the ACDs in Ireland and in the UK, and they're all available on our website under technical resources if you want to have a look at that. And hopefully this will give you some insight. How you do it, I'm sure you guys know at this stage, but you just measure the lengths of these junctions, any junctions that's popping up there right now, and those, your jam sills, lintels, etc. You multiply them by the factor that I've just shown you, those figures, and ultimately it comes out with this little calculation here. You get your Y value at the end of the day. And we see Y values as being very important going forward. There's a lot of developers will say to us, we want to achieve a better energy rating on our house. Do the Y value calculation. It will improve the energy performance of the house easily. We've had a lot of people saying they want to cut back on insulation.
Oh, you've just been muted there somehow, Phil. Wait a second, I think. Maybe you could unmute yourself. Is your unmute button not working now? Oh, there you go. You're back.
I don't know why that's happened. Sorry about that.
Okay, bugs in the system. Fantastic. Keep going.
Something to do with your system there. There we go. We're back on. So yeah, look at the Y value calculation, guys. We have our own little calculation that we do in-house to get the Y value. It's quite simply the junction, the length of the junction by the side value, total added up, divided by the total envelope area, gives you your Y value. Of course, you need to be using as well the SEAI one, but you could always verify it with ours, whichever, quite simply. Of course, signing off on the ACDs is still very important. I know rules have changed over the last while where even a one-off house owner can sign off on their details. I personally think that's a terrible idea, because who isn't going to sign off on their own details on the house? We've got it signed off there by an engineer to say that all of these details are correct. But I would say, for your own benefit, photographic evidence that is showing the perimeter strip being installed with the insulation. Let's click again just to get a more improved version of it. I do think that you guys should be signing it rather than the homeowner, but that's up to yourselves. But that's is key for the future to look at what we, to prove that the Y value is correct. going on. And this is a good register for later on for your third-party certificates, etc. So use it. Where do we go to next? Look, guys, there's something in the pipeline called the RI AI 2030 Climate Challenge. I have an independent presentation on this. If ever you want it, I'm happy to do it for you. It's quite intense. I would say that this is more down to architectural side of things, but we are all included in this. The RIAI have decided they want to go down the climate challenge route, which has been in since about 2019 with England. England are going to bring it into their regulations this next year, 2025. When they do, it will come into our regulation 2025 or whenever we rewrite the regs. It was written back in 2021, this detail, and it's ultimately about looking at the embodied carbon of materials. Now, that's not anything to do with the BER assessment at the minute, but it does state that all architects, engineers, assessors, people like ourselves, we're all involved in reducing the climate emergency. So you may well get involved in that going forward. If you do, we have a few results that might be able to help. The Eco 360 range, for instance, is massive in terms of looking at embodied carbon. It's the carbon associated with making this product and letting it live in the life of a building forever. So there is a full fill version, there is a partial fill version, and there's an 8x4 MA, which is our multi-application board. It is bio-enhanced with rapeseed oil. It has improved thermal performance down as low as 0.020, probably the lowest we can get at the minute. It's reduced packaging down as low as as high as 70% reduced from what we currently have on our wrapping of products. The wrapping itself is biodegradable, so it can go in the ground and disappear through the course of its life, disappear very quickly actually. And there's less waste on site that ultimately we look at the drawings in our technical office. We tell the developer or whoever, the house owner, how much insulation you actually need to use on site, and therefore there's less going in the ground or whatever. But this product itself will be fully recyclable eventually when it comes to it. There is a slight up on the price, increase in price on it, 10-15% depending. But look, if you've got any big developments going on, give us a shout and we might be able to bring the price down a wee bit on that, you know. But think about it going forward. And I know it's not in regulation yet. I'm sick of hearing architects say it's not in regs, we don't need to worry about it. It will be coming out in regs. For many years, I spoke about thermal bridging not being in regulations, but it was coming. Sure enough, it did. I'm now doing the same with embodied carbon because I know it's on its way. So please have a look at it. It was written into the European directive in February this year. So now that it's in that, it will come into our regulations. Guys, that is about that. I said 45 minutes. We've been exactly 45 minutes. There's my mobile number, my email address. There is also another number on there, which is straight through the technical office, but I would say speak to me first and I can direct your request on to wherever is required. And like I say, my email address there is sitting there and filled up ward at unilin.com. It's a handy one to have, nice and easy to remember. Bombard me if you wish, and I shall help you out as much as possible. But the main thing is getting the U-value calcs right, guys. This thing about the flaws in the BRE software, this thing about the cavity walls, the wall ties, be very, very careful, because if you go to the limit on the flaw and you're using the UK detail, because it's UK software, it will fail the building regulations if ever audited properly. All right, guys. But that is that for today. I'm going to stop sharing now, and Stephen, maybe you can come in if there's any questions. I'm hoping there are some, but if not, fair enough.
Yes, thank you, Phil. Phil, thank you very much. That was very informative. I think you went a nice mix there of what was the kind of basic stuff and then some more complicated stuff. So I certainly took note of a few things myself in there after all the years I'm doing calculations. So no, that was absolutely fantastic. We have a few questions in, so I'll start with the first batch of them, and then maybe my colleagues Liam or John might hop in with any of the ones that pop up later. I see they're actually popping up. So yeah, we'll try to keep it to maybe 8 or 10 minutes, and we let it go then. So the first question came in, obviously, some of them we can get through quickly because they came and then you went on to actually talk about it. So the first one just that came in was showing how well informed our assessor community is. Will we see big changes in material types with the inclusion of mandatory embodied carbon reporting? So obviously that was exactly where you were going with the last one. So
Yeah, we
we're
will.
going to see that. And I suppose a lot of us are worried about the thermal conductivities of some of these materials, but you demonstrated that they're actually still going to be pretty low, so we're not
Yes.
going to be having issues with that. So we'll go on to, can you comment please on options to upgrade traditional stone walls? So kind of, it's
Yeah.
very
So
topical at the moment.
stone walls typically have the lime plaster, lime mortar. If they have those, we have no option but to say we don't have any products for that. It has to be a breathable product on the inside. However, I've worked with breathable guys before doing the insulation, and what I find is they use a breathable insulation, then they put a plasterboard over it and plaster it. That is no good to anybody. It needs to be a breathable solution from the inside of the building where you're standing out over and the outside of the building in over. So it all has to be breathable. Otherwise, you'll have masses of condensation buildup, etc. So we don't do a product for that, but it's breathable insulation. If I was to say something like Moy Ice Over, you might be able to get a product from them.
Yeah, we've had some of the guys on from different products in the past here. So go back to some of our webinars, I would say, on the members area, and you'll see fantastic presentation by Ecological Building Solutions and the likes on the options that are there. Another one that you probably answered, what is the adjustment for stainless steel wire ties? So I think you went through that, and there was a follow-on question a little bit later down. About getting certification for these ties. So I guess the company here in Ireland, Ancon, I think it is, they're quite easy to get. But apart from that, it can be very hard. Well, first of all, to get somebody to specify it on us and name what product they've used, and then actually for us to try to get the thermal conductivity of the stainless steel, etc., and the number of ties per. So I don't know. Do you want to comment anything further on that?
We actually supply out wall ties with our insulation, and they are Ancon wall ties.
Okay.
So we actually sell those out as part of the deal. I know we don't manufacture them, but we have bags of them that we buy from Ancon. But I mean, they are just the standard stainless steel Ancon double triangle wall ties. So you can get all their data from their website as you can for our product off our website, But no, it's all down to the manufacturer of those particular materials. And I was actually asked this morning on the way back home to do this presentation about a breather membrane we'd had on a calculation, and I just had it in as a basic breather membrane, and the architect said, could we have the specific product details for that? And I said, no, we've calculated as a standard breather membrane. You can use whatever breather membrane you want as long as you contact the manufacturer of that product and get the details of them. So same applies to wall ties.
Very good. Please compare internal to external wall insulation. I suppose what they're looking for there maybe is probably looking for pros and cons, I would imagine.
Yeah. Well, I suppose the pros and cons are if you do it internally, you have a lot of work to do in your house afterwards. It is the cheaper option because they state that if you were to totally replace all your tiles, carpets, etc., it works out about 70 to 80 euro a square meter to get it up to the standards that we look at B2. If you do it externally, you're looking at somewhere between 130 plus per square meter, and you have to move your wall boards out, you have to move your window boards, you have to move your gutters out, you have to move your drain out where you walk out of your house, there's a shore down there, whatever. But also a lot of people don't realize that you cannot externally insulate a cavity wall because all of the heat comes from your house into the cavity and up into the roof. And it does never touch the external wall insulation.
Your thermal looping comes in there,
yeah. It's often people often say, "Oh, we've got a hollow block wall." Well, you can't insulate that. The heat will get into the blocks, away up through the blocks, into the roof and away. It never touches the external insulation. So we'd rather not sell any insulation to that aspect, but we do sell grey polystyrene that the likes of Kilsar and Concrete Store would buy off us and fit as a system and give a warranty for that system being fitted with the render, etc. But ultimately, no, I mean, look, I would always do internal insulation. I've done it in my own house here, but I just purely because of the build of the wall and where the drain comes down off the roof, I would have to move a lot of drains out and then relay new paths, etc. A lot of work to be involved in. You know,
Definitely pros and cons. And the thermal bridging, I guess, would lend you the other direction,
of
maybe.
course, yeah.
But yeah, there's pros and cons in it.
Yeah.
Yeah, absolutely. Okay, so is a good one. Have Extratherm got Unilin? Have Unilin got certification for resistance? Yeah, so basically, we're going to justify these calculations to our auditors. Having a
Yeah.
separate document that will satisfy them audits, I guess, for the emissivisity of the file back.
100%. It's in our NSAI certificate. And if you want to go onto the BBA website, you can download my certificate. You can download the other guys that actually type in Phil Ward. My certificate comes up there to prove that I can do competent calculations as the other guys,
Yeah.
and use that with the NSAI cert saying what the emissivity is of the product. And if you can calculate that properly, then that's your answer. And yes,
Yeah.
SEAI cannot refuse.
And once that product is linked on your document signed off by a competent
100%.
professional, then you shouldn't have a problem with that.
100%.
Stephen H. had a long one here for us. In the U-value example from the U-value calculator, it shows that the blockwork conductivity is 1.133. Within SIBSE, the concrete blockwork is 1.31 for heavy blockwork, and there doesn't appear to be any blockwork with a conductivity of 1.13. The U-value calculation received from Unilin has the blockwork for a dense block inner outer leaf to be 1.113 and not 1.31 as per SIBSE. It has happened on a project previously where the block work was changed to 1.31, increase the U value by 0.01. It's only happened once, so it can make a change, I guess. Yeah. So
yeah. It's industry standard that if you look at our calculations, Kingspans, Mannix, you name it, throughout the business, 1.13 has been a standard dense block for many years. It's not in the SIBSE guide. I get it's 1.33. We know that. As I said, the SIBSE guide is worst case scenario. If you look at insulation, for instance, my insulation is in the SIBSE guide is 0.026 lambda value. I'm now down at 0.020. Okay, so it's not our insulation, but our type of insulation. So we understand that most dense blocks could be a little bit higher, but it's an industry standard to say, if you want us to use 1.33, we'll use it, no problem at all. We can get calculations down as low as 0.13 or lower in a standard 150 mil cavity. So you don't need to go that low ever. So look, give us the right details. We'll use whichever one you want. But again, the problem there is if we say it is a standard dense block at 1.33, they could well be using a better block from somebody else and never tell us. So it's which way do we do it? So I would say to whoever put that into us, by all means, ask us to run some calculations using the other blocks. It's a masonry industry standard to use that figure for the block work.
Yeah, and generally it's the insulation thickness that makes the big difference anyway. We're getting to fine margins there. The next couple of questions I think have been dealt with by yourself there. So maybe Liam, have you any more recent ones that have come in there since I started writing?
Yeah, thanks, Stephen. And I have one of my own as well, Phil. Before kind of go on to questions, I just want to give you enormous credit for an excellent presentation.
Thank you.
We've had some very good feedback there from people, and like Stephen said earlier, I found myself taking notes as well. I feel we've only scratched the surface of your knowledge there in an hour, so really appreciate that. And you were saying before, the last time you did this, you had 29 people. I can assure you had more than 229 this time. So hopefully that's made up for it. One of the things I wanted to just tackle you on was the thing about the stone walls, because I've been involved in a project recently where the architect has specified a kind of we'll say like an internal house within the stone wall using PIR. What do you think of that approach? It's like there's a ventilated cavity between we'll say the timber stud with the insulation in it, and then the stone wall from the original house.
So technically that should be okay if it's a ventilated cavity between let's say they're building a new blockwork or whatever inside the new timber frame. If you've got a ventilated cavity, it's ventilating that block, so it should be fine. The block should be fine because it will have the lime mortar or whatnot. However, it's more so when you're insulating either onto battens or directly onto that wall that is the issue, because you're creating an air block, whether it's your plaster. We actually had a guy come down and try to create a ventilated wall using a phenolic insulation. We were trying all different kinds of things out. And he took a day at least to plaster an 8x4 sheet with a breathable plaster. Now, I don't know any builder in this country who's going to plaster a whole house at 1 day per plasterboard.
Yeah.
Right.
Yeah.
It just doesn't happen. And I know so many cases where it should be a breathable wall, but they add things on and it becomes an unbreathable wall. In your case, I think you'd be fine as long as you have got a ventilated cavity between the inner block, the inner construction and the block work, and then it's ventilated obviously from the outside. So you'll be fine with that, Liam.
All right. Thanks for that, Phil.
Yeah, no problem.
So John Barrett also has a question there. Do you account for the unventilated space behind a knee-high wall on the first floor of a dormer house when you specify insulation?
Yes.
The U-value for the knee wall includes the internal wall, unventilated space and insulation in the slope rafter. This is when air tightness line runs along the external wall onto the slope of the roof.
Yeah. So there's different, how would you put it, different external surface resistances to use, depending if it's just an outside wall or outside roof or a semi-exposed, which is what that is, the knee wall. If I'm thinking right, the dormer stud wall. There is a different surface resistance to use on the outside. Again, BR443 describes what to use there. It gives you the resistance to put in. And on my calculations, it would be in as 0.13, I think, as the surface resistance. It would be a higher figure for that.
Okay, so, yeah. Thanks. There's a question about wall ties as well from Stephen Howland, and I'm just going to give a little bit of promotion to Stephen here and other people on the Facebook group for Bar Assessors who are very active, and I'd just like to thank those people who contribute a lot to that, and Stephen's one of the most active contributors there. So his question's very specific about wall ties, and he's saying, you know, that if the architect doesn't provide the details on wall ties, then you have to use the worst case scenario. But that he said it's often the case that architects will say they don't know anything about the wall ties and they were never asked about it. He's asking, are they being asked specifically for the details? And if defaults are used, it could result in a different U-value than what is used on site. And I think that was exactly the point you were making, Phil.
Yeah, look, I mean, to be frank, in the UK, they tend to use strap ties all the time. Right?
Yeah.
In Ireland, we don't do that. I'd like to say I've never seen a strap tie on site. I have once or twice, but it was a huge, wide cavity, 400mm width cavity, for some bizarre structural reason. In Ireland, we use the double triangle stainless steel with a little drip point in it and sometimes a little disc on it to keep the insulation tight back. The architect typically would have every drawing I've seen has the wall tie detail on, but if you're getting drawings that don't have, I think the architect should be specifying it because it is a structural element. It's got nothing to do with the insulation. Right? It's a structural element between the inner leaf and the outer leaf to hold them together.
Yeah.
That's all it's for, realistically. It's just been designed so that insulation can be incorporated within the cavity. But I would say that the 90% of the wall ties in this country are the Ancon double triangle stainless steel. Right. If you go to any builder's merchant, I was in a builder's merchant this morning. Unfortunately, my boiler packed in this morning. If you know any good plumbers around County Cavan, please, somebody let me know, will you?
Right.
Hint, hint. But I saw wall ties sitting on a big shelf as we walked through next to our insulation. It was all Ancon, all of it. So I think the majority are the Ancon double triangle stainless steel. There are other double triangle stainless steels that we've had from down south as a country, Vartry Engineering. They do exactly the same material, exactly the same wall ties, same dimensions. So it's pretty much of a muchness. But like I said, it's just the strap ties. You go from 13mm cross-sectional area to 80, and it's a huge amount more steel when you add it all up in your thermal bridging detail.
Sure. Yeah. Okay. So just one final question. It's from Rory McKevitt there. Hello, Rory. So this isn't really about U-values so much, Phil, but about fire rating. And he's saying that he observes that there's an A1 fire rating on fiberglass, and he would prefer not to add PIR in attics beside electrics. So what fire rating recommendations do you have for adding to attic spaces?
Like you can use PIR, it's not a problem. The only
Okay.
thing you are supposed to do is when you have cables in an attic, they're supposed to be in a conduit if they are next to or incorporated within insulation. It doesn't need to be non-combustible insulation up there. We have plenty of people using just PIR within the rafters or whatever, and you have cables going up there. I think we all have to be very careful since Grenfell talking about fire ratings. And everybody's jumped on Grenfell, and Grenfell was a disaster. I'm sorry it happened. Disaster of a thing, but there's a lot of constructions that have nothing to do with fire rating, and having a few cables running through a bit of insulation, nothing needs to be fire rated there. It just needs to be in a conduit and that really comes down to polystyrene, that if you put a cable through a conduit and the cable heats up, it will keep heating up because of the polystyrene around it. The polystyrene will eventually melt. You will have an issue or whatever there. So, but with PIR, and there's no issue when it comes to cables going through your attic space there. So
Okay, that's fine. Thank you for that, Phil.
no problem.
So that's really it, Stephen. I'm going to give Stephen the last question. He asks, is there a U-Value certification course in Ireland, like in the UK? I don't know if you are aware of that, Phil.
No, there's not.
No. So
No.
we'll have
You're in it. You're in it right now.
You're in it now, yeah.
This is the one. The only one we could possibly find, apart from, I mean, there's some in France and whatnot, the only one we could possibly find was the BBA TIMSA scheme. Now, it is accepted in Ireland since Brexit, and, says the English fella. But hey, look, I've been here 22 and a half years. I should be proper blowing by now. I would say get onto it if you want. But I mean, I'm going to be honest with you. It was majorly intense. It took me 3 weeks to do 14 calculations, and it was all done the R1 plus R2 plus R3, blah, 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 blah. And they give you the most difficult scenarios, the steel frame, the timber frame details to do, flat roof with a parapet wall, blah, 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 with a bit of thermal bridging. It took me 3 weeks to do 14 calculations. I could do 14 calculations in about 10 minutes on my computer if I wanted to now.
Yeah,
right?
Of course. Yeah.
So it's not an easy thing. If you want to do it, go for it. But there's no scheme in Ireland. Unfortunately, there should be, but unfortunately, there's not. So the BBA TIMSA scheme, if you're really, really interested in that kind of stuff.
Well, maybe we'll get you back, Phil, to do some of them more complicated calculations that cause problems with facades and the like.
Listen, we can do those calculations on our systems, and the systems we use are accepted by the SAI and.
Yeah, I think it's more complicated. Those in the commercial world here find that more complicated getting, and a lot of architects are not certifying. They're asking the assessors to certify some of this. So we could certainly do it some more in-depth knowledge on how to stand over our calculations for commercial buildings and that. But somebody else just asked there a very important question. The numbers are dropping there, so we should finish up. Is the CPD points? So we've downloaded a list of everybody that's on today's course, and we'll supply that to Phil and his team in Unilin, and they will supply CPD certs. Is that right, Phil?
I will indeed, yeah.